Well, it's that time of year when the hearts of weather weenies around the world are thinking about blowing snow and our upcoming snowstorms. But there are some disadvantages of blowing snow as well, such as the large snowdrifts that we saw over closed down Lakeshore Drive in Chicago a year ago. From a scientific standpoint, there are some interesting questions about blowing snow, one of which is, can blowing snow actually cause heavier snowstorms from low clouds, such as lake effect snow clouds? Well, when we think about this, you have to consider how snow is made. Most snow in the inner atmosphere occurs in liquid clouds, which you can see here with the dark clouds in this picture. And some of that cloud is converted over to snow, and you can see that falling from the cloud. But in order for that conversion to occur from liquid to ice, you need something to get the ice started. You need some kind of nucleus. And the question is, can blowing snow be a reason for that nucleus? Some great examples of what happens when you get snow forming in a liquid cloud are these pictures. These are hole punch clouds. In the middle of the hole punch clouds, you can see snow that's falling down to low levels. And you can see a nice little hole in the clouds because the cloud droplets have been evaporated and the moisture has gravitated and moved over to the snowflakes, making them large enough to fall down to lower levels. We don't see those very often around here. So the question is, can blowing snow increase snowfall? Can blowing snow be the crystals that we need to start snow formation in liquid clouds, especially at low levels? To investigate that, we can't stay on the ground. We have to go out there and take measurements in the clouds themselves. For that, we use the University of Wyoming King Air and some other aircraft that are available. The King Air is a rather odd-looking aircraft. You can see things sticking out of it, all these instrumentation. This is what it looks like looking out the front window of the aircraft. This is in a lake effect snowstorm over Lake Michigan. Lots of turbulent clouds that are bouncing around. And the flight scientist sits in the co-pilot seat. This is looking back into the aircraft from that seat. And it's rather tight. There are a lot of computers in there instead of people. There are a couple of students here that worked with me. You can see they were smiling, and that means it was the beginning of the flight, not the end of the flight. So to study blowing snow, we needed to go someplace where we know blowing snow is going to happen so we could study it. For that, we went to the ASCII project, which was headed by the University of Wyoming. And the idea was to look at blowing snow that develops over the Wyoming Sierra Madre mountain range. And there's a picture that I took of a plume of blowing snow off the top of one of the mountains. I'm going to talk a little bit about one particular day that we flew. It was 18 January of this year. It was cold out, but especially it was very, very windy. The aircraft was flying only 2,000 feet above the highest peak. But the winds there were the same as Hurricane Sandy when it came on shore in New Jersey, hurricane force winds. That was our flight plan for that particular day. We flew this 2.5 times. I'm not going to explain that statement. But in that one particular area, we saw snowflakes at the altitude of the aircraft. Well, if you look at temperature, humidity data, turbulence data, and other things, we try to estimate where the snow came from, and we actually got quite a mix of ideas of where the snow came from. Some estimates were from above, some were from below. To get more of a hint of that, we used an airborne Doppler radar, which was pointing straight down from the aircraft. And you can see right near the peaks of the mountains, you see these blue patches that are higher reflectivity, which indicates that's where the blowing snow is. If you look at the motions of those particles, if you look at the bottom panel there, those red colors indicate that the snowflakes are moving down. And that suggested that what had happened was the snow was blown up above the altitude of the aircraft and then flew down to, settled down to where we were flying. So what's that have to do with the Midwest? Well, in lake effect snowstorms, which we see each year, the general idea is that liquid clouds form first, snow develops and eventually dumps on the downwind shore. But a student working with me recently found that there is a lot of snow that occurs before the first clouds are seen. And it raises the question, where did that snow come from? So our current work is trying to understand how we can measure blowing snow to see if that's the reason for that mystery and try to figure that out. And clearly from our observations, blowing snow can get up to the altitude of clouds and so they might be important.